All right, everyone. Welcome once again to the Faces of Business. I'm your host, Damon Pistolka, and with me today, I've got Jennifer Herron with Action Engineering. Welcome, Jennifer.
Hi, Damon. Thanks for having me.
I'm so glad we could get you here. It's been a while. It's been a long time coming because I'm really intrigued by your business now and your background as we talk about uncovering opportunities with the model based enterprise or model based manufacturing, because I think this is something that a lot of people are really considering now, that it used to be relegated to much larger companies, or really haven't considered as how, if they adopted the model based approach throughout the organization, how it can really streamline their business.
Right.
Yeah.
Yes. And it can.
Yeah. Awesome. Awesome. So let's hear a little bit about your background, Jennifer, because I think I always like to do that and you got some cool junk in your, not junk, but cool work
Cool
experience.
work
And
experience.
yeah. Yeah.
Yeah. Yeah. Well, we were just chatting before this, and I went to Washington University in St. Louis, and that's where my bachelor's degree in mechanical engineering is from. Um, I also have a little bit of a separate side of me, which is a performer side. I grew up dancing, ballet, and then did jazz and modern in high school, and also did some musical theater stuff in high school. And then when I got to college, one of the reasons I chose WashU was that I could do some little bit of theater. And I also learned to do rhythm tap dance, which is my absolute favorite still. Um, and I still do it.
Wow.
And so I'm a little bit unique from that aspect, but it was fun to be able to combine and mash up theater stuff with engineering. And I think I even talked my dean of engineering into not doing some English classes because I could do dance as my electives instead. So
There you go.
I'm a little clever that way.
Yeah. Oh, that's
Yeah.
awesome. That's awesome.
Yeah, and then what I ended up doing is kind of my work jobs while I was at WashU. I started working with a professor who was working on being principal investigator for some Mars missions, and this is back in the 90s, so it's early on in the days before we have the big rover that we just put there now, and so I ended up as my first job working at Lockheed Martin here in Denver, Colorado. And I did several discovery missions, spacecraft related. So there's space stuff behind me. And
Yeah.
yeah, and then I also did unmanned ground robotic design also, where we were putting together robots, where we basically took an ATV and took it apart and automated it, and so it could drive itself. So,
Hmm.
yeah.
Wow. That's crazy, because I mean, when you think about the critical nature of anything in space, it just basically can't fail, or if it
Right.
does, there has to be something that just takes over, a backup
That's right.
system of some sort.
Redundancy.
Yeah. Yeah, because it's not a good result if something fails. That's
There's
for sure.
nobody there to fix it.
Yeah. Yeah.
Yes.
So the kind of stuff that you were working on, is it mainly unmanned kind of that stuff, or
Yep.
was it? Okay.
Yeah, unmanned, and I did have a stint with both Orion, which was a capsule kind of modeled off of the old Apollo
Mm-hmm.
system. And then also I worked on Dream Chaser, which is a lifting body for people as well. So the manned activities are uh, obviously more serious from a criticality standpoint than the unmanned. The unmanned, we were able to work redundancy in, and if eventually if it failed, kill anybody.
Yeah.
So
Yeah.
yeah, so a little bit less critical than the manned missions, but obviously we still do it today. So
Yeah. So
yep,
I was thinking about designing space equipment.
yeah.
What what was what was something that you go, I never thought about
Hmm.
this?
About something that I designed.
Yeah, you just like, I would have never thought that I had to consider that.
Yeah, that's a good point. Uh, Probably the cleanliness of things. So, very early in my career, I ended up working on the Stardust mission and the Genesis mission. Both of them had a substance in it called aerogel. And aerogel is this kind of like baked out silicon something something. And I used to have some sitting at my desk, but it's since like crumbled and dissolved by now. But it was a clear foam, but it was super super dense. So we unfurled, we called it the waffle grid because it just looks like a waffle. We
Yeah.
unfurled that and stuck it in the tail of a comet, and then we collected the space dust, and then we brought it back in to the capsule, sealed it all up, and then deposited it back in the desert for pickup and analysis. So I think what was most interesting there is, as the rookie engineer on that was, okay, we have to seal that system up, move it around the country so that we can get aerogel populated. Had to have nitrogen purge and things like that. So we had to keep it really, really clean to leave Earth so that we weren't putting contaminants out into space and then saying, oh, yeah, look, well, we got,
Yeah.
did you know there are bees in space or whatever, right?
There you go.
I was just thinking you can't have little bees like in your aerogel. So probably the cleanliness factor was most interesting, and there were some complex problems to solve in that aspect.
Yeah, no doubt. And I mean, when you see the pictures of it, like when they're doing a telescope, it's crazy.
Yeah.
The clean room environments they have to do. But that makes sense if you're going to collect samples from space. You don't want to contaminate, like you said, with a bee or a fly or specks of dust or whatever.
It's really specks of dust, right?
Yeah.
The bee's going to be pretty obvious.
Yeah, they'd see that.
I think we should take that out.
Yeah. So when you were doing that, before we got on, you were talking about, you were obviously helping people with model-based enterprise work and helping people do that. You started designing in solid models from the beginning.
Yeah, from the get-go.
Yeah.
I know people complain now, oh, that college kids don't learn how to draft. And I said, I didn't learn how to draft. And this is my 25th anniversary of graduating from, with my bachelor's degree. So, okay.
Yeah.
So, we always made a model, and then that model gets projected onto the drawing, and then you'd add your dimensions. And what we advocate now is that instead of that step of creating that 2D static drawing, leave it in the model, add your geometric tolerances with the solid datum reference frame, your geometric tolerances to define the engineering requirements so that it all fits together when you get it back. But then that conveys the information to the manufacturer that allows them the flexibility they need to make the part however they're going to make it. One of the things we get is, we can't use geometric tolerancing because it's too expensive to build. Well, I can put a big profile tolerance on that stuff and say build this within a 1/10 of an inch. That's pretty big. It's a lot of flexibility in your part. So that's what we're doing, is defining the mathematics of the tolerances in the 3D data set so you can view it and see it. And then also other machines can read that information and interpret it.
Yeah. Wow, that's amazing. That's amazing, because I lived in the old world where you took the 3D model if you had it, and then you make that, and you get the 2D, and that's how you do the actual measurements and everything else, because you're either on the model itself measuring features and writing a number down basically, and doing it, or creating the drawings from the model. But you're saying that the dimensional data actually resides in the model itself, and there's no need to create the drawings.
That's right. You got it. Yeah. And then, if you scan it with a scanner, or if you use a CMM tool or whatever your methods are for inspection, then you could just compare those two pieces of digital data together. And then there's great software tools that allow you to visualize how they're out of spec. And, if you're an automotive supplier, for instance, you're building hundreds and hundreds and hundreds of parts, and probably more. And so you can see how your machine tools are operating, that OEE, the operational equipment
Yeah.
effectiveness, and make sure you're hitting the mark every time. So there's a lot. There's a lot of opportunity once you digitize the data solidly with mathematics that it has machine readable information.
Yeah.
To capture the engineering requirements, and you could do lots of things in the fabrication step and lots of things in the inspection step.
So backing up to when you were starting and working on the space systems, were they
Yeah.
already doing this kind of stuff then in that realm, or was it really going to the drawings like you're talking?
Yeah, you know what, Damon, it's really funny you say that, because just today I grew up here, and I grew up with my job, here in
Yeah.
Colorado, and
Yeah.
I've been in Colorado for, I guess this is going on my 26th year. And I said, we used to go to machine shops locally here all the time because we built funky, weird parts, and we built one or two of them. So I did a lot of research and development work also. So we were always kind of able to talk to the machinists directly, which is a great way to grow up as a designer. And pretty much 100% of the time, I gave them a model to start with. For the most part. And then, I still, at that time, there were no annotations where you could add, the tolerances and things like that. So I'd still have to provide a drawing, but we were always seeding it right off of a model.
Yeah.
And then I even had a machinist teach me how to take that model out of a DXF file and then CNC directly from it. So in fact, that it's a little Mercury capsule back there.
Mm-hmm.
I designed that and then popped the DXF file into the CNC machine and then machined out the Lexan. I don't know how long ago, probably 21 years ago. So yeah, we've been
Nice.
doing this for a while.
Nice. Nice.
But the software tools, the CAD software tools, are way better,
Yeah.
more easier to use. They're more robust. They really are creating a lot of digital connections that give us traceability through that whole cycle, so that we can start eliminating manual data reentry steps.
Yeah. Well, that's what I think is so amazing, and because honestly, I haven't been in a technical role in a manufacturing. It's been 15 plus years, and in that time frame, I knew how to use the whatever it was, the salt. I can't even remember what the name of it was. The one that
CATIA.
Boeing and the CATIA. Yeah, I knew how to use CATIA enough to be
Yeah.
dangerous, right? And
there
and
you go.
I could pull up the model and measure stuff off. That's about all I could do.
Yeah.
And and now the systems that you see, even from then until now, are so much easier, and the integration between systems is so much better. I mean, and at that
It
time
is.
you couldn't really go. You could, but it was not just a boom boom to go from there into my CMM or my measurement system, whatever I'm doing,
Right.
and then just
Right.
measure right off the model. That was just
Right.
like almost unheard of.
Right.
And and we were building stuff for the F-22s. And
Yeah.
so, it was all model based.
Sure.
Everything was model based on it, but it was clunky.
Yeah, I think it, clunky is a good way to say it. And I appreciate that you bring it up, that, it was worse than it is today, because there's still a whole lot of whining about the tools. Of course, they probably will always be whining about the tools, I suppose. But it is definitely, there's been a lot that's happened in the last 15 years to evolve the technology. There's just a lot of players in the space that are working really hard to bring the value of digital data and keep it all traceable, and hopefully make it less clunky. I'm all for less clunky. That should definitely be the
Well,
end
yeah,
game.
because looking at it from a business perspective,
Yeah.
if when you get everything working together, and it's not like I've got to convert this into that, and then there's some, and you really get it so it's integrated, it's got to be a really pretty incredible to see a system like that working together
Yeah.
in a manufacturing system, manufacturing setting. So let's talk a little bit about, so you were doing the space design, you're working for Lockheed Martin and such, and then what prompted you to form
Do
your
something
company?
different.
Yeah. Why did you decide, oh, I need to go out and teach people about model-based manufacturing and becoming a model-based enterprise?
Well, clearly it's because I'm totally obsessed, but and that is somewhat true.
Well, yeah, that's
Yeah,
a given.
it is a given. I've come to realize, actually just recently, I said, you know what, I think I might be addicted to efficiency.
Yeah,
And that's actually a really good thing in my business. It's perhaps not such a good mental health thing, to
yeah,
always try to be efficient all the time, but I definitely addicted to efficiency, and I loved modeling things and making the models efficient. And on top of that, I had a couple of different jobs in different places, and we changed CAD tools. So, I mean, I started out life at the very, very beginning using UG, Unigraphics.
yeah,
Then I learned Ideas Master Series. Then I learned what was Pro Engineers, now Creo, PTC. Uh, then I learned SolidWorks. I'm trying to get this all in the right chronological order. And then I learned NX. So all the tools really are exactly the same. They just have a couple different button clicks, and they have a couple different variations in, what they can support and what their quirks are.
yeah,
We know a lot of their quirks. So from kind of all those experiences, I just found patterns in the way I was working in every single CAD system. And so I thought, okay, this is an opportunity for me to sit down and categorize this information, and um, and then share it with others, because it was a body, a text document that was missing.
yeah,
I really do believe in standards and standard working procedures, and um, again, sort of my efficiency addiction.
yeah,
And so I was always trying to build instructions and tell other people how to do it. So um, then that's when I sat down and wrote my Reuse Your CAD book.
yep,
And that first edition was published in 2013. And then this year we published a second edition that includes some, not all, of the of the learning that I had in the last 7 years. So
yeah,
yeah.
yeah. So let's talk a little bit about your book. You wrote the
Okay.
book. So
Why?
what it's a yeah why what's the book help people figure out?
Well, yeah. So again, totally obsessed, and I could see patterns, and I could see instructions that if people would model things in a certain way, then we would be able to consume it or reuse it, or if you got hit by a bus, another designer would be able to pick it up
Mm-hmm.
and use it, because it was built in a standardized kind of sensical way. So the first release of the book really focused on CAD modeling, large assembly modeling, how to create assemblies that could be used in parts lists, that could the individual piece parts could be consumed in machine tools, and but primarily it was all built for designers,
Yeah.
to say, hey, designer, here, I'm leaving today, I'm going to hand this off to you, you finished working on what I'm working on. And so it was primarily built for that, but what we learned in the last 7 years is that um, or 8 years really, there is a lot of benefit to the downstream consumers if they've got that 3D model already. Then they're a step ahead of the game, and they're not trying to misinterpret anything coming off the drawing.
Mm-hmm.
Because what's
Wow.
on the drawing is just 3D projections, and then you got to like unfold it and unfurl it in your head to create a 3D model. So we discovered there's lots and lots of benefits to those consumers of that 3D data, but that we'd have to present it in perhaps a different way than we're used to looking at it as engineers, because we're engineers and we're addicted to efficiency, and
Yeah.
we know way too much math, stuff like that.
Agreed.
Yeah.
I'll just go agreed on that part, because if you don't know an engineer, yeah, just hang around one for a while. Yeah. So
We're into the details.
Yeah, a little, yeah. And people that are around me understand that very well, and we're always fixing things. That's the other thing.
True.
It's like, hey, it's broken. I can't walk away from it. It's
Let
broken.
me fix that for you. Yeah,
Exactly.
that's right.
Yeah. Oh, we go down that hole a long ways, because that's an ugly thing to try to break.
Yeah.
But so you're doing this now, and you're helping people do this. So what are some of the enlightening things that people really see when they go, okay, we're going all in on the model-based enterprise. We're going to do this. So when they start to do this, what are some of the things that you see that they really benefit from?
There's two really, really big categories. And then there's lots of things that can be derived from those big categories. But let's say the first one is about eliminating waste. There's a lot of waste in how many people touch a particular product in the documentation today, and some of that is because we needed that for the drawing based methodology. They used to draw ships by hand, and then they used to have another person come and redraw the ship to make a copy. I think those were things that was the state of the art of the technology at the time. So we're looking at eliminating waste, and this kind of brings me to my second topic, which is we really want to help out the employees of your company by taking the tedious stuff off their to-do list. If it's stuff that's just, I'm just clicking and clicking and clicking, or I'm, manually transcribing from here to here, there's a lot of copy paste from spreadsheet to spreadsheet kind of activities. If we can build in that digital traceability where they can trust that the data is maintained pedigree throughout the transitions, whatever those transitions may be, then those people that you have doing all this ridiculous manual labor can really use their carbon-based brains for what they were intended for, which is solving complex problems. Yeah. So that in and of itself, there's about 25 different capabilities that we've come up with in the model-based space that help to persist accurate, trusted data from design through fabrication, through inspection, and then oftentimes there's a supplier loop, right? Mm-hmm. You have a big supply chain of data and information exchange. And what we want to do is create feedback loops through all those four kind of typically siloed areas within the manufacturing space. And if we start creating feedback loops, then we start to be able to improve our product in a much better way. Yeah.
So when you talk about the eliminating the waste, what are a couple examples of that you see that people go, wow, this has really impacted our business?
Yeah, this is several years ago now, but we ran a basic pilot with an engineering organization that handed their data off to a supplier. And one of the great things about this particular project that we ran was that we were able to be intimately involved in all of the steps on both sides.
Okay.
And the reason why I say that's important is because a lot of times people just throw their information over the wall to the supplier and say, you deal with it. You don't always get the result that you want when you do that, especially in these kind of transition activities where you're trying to like, I gave you a drawing yesterday. Today, I'm going to give you a model. Good luck, you know. So what we learned in that process and that data exchange, you know, that the data went out from design to the fabricator, and then they pulled data back in because they were pulling first article inspection reports, and they wanted to see all that feedback loop in that data. And so there was, like, you know, digital models on one side where they engineered, and then on the supplier side, they often took that model kind of like as a step file or something like that, and then they started playing around with the model and building tooling. Sometimes they built in-process models and things like that. So looking at kind of that workflow and diagramming it up, we found as many as 20 manual data re-entry of data through that process.
Wow.
That's 20
Yeah.
people, 20 brains manually re-entering data. And one of the common pain points with where people live today, even if they're using a model like a step model, is their step model geometry doesn't actually match the drawing. And now everybody's in a pickle. Both the
Yeah.
engineering side and the supplier side all in a pickle. So we took that manual data exchange and reduced it. And in the geometry case, in the case of where we're just representing the geometry of the product itself.
Yeah.
And actually, I've got a visual aid for those who are. So if I take the geometry of this product itself, and I transfer it from the engineer to the supplier, and I run a verification and a validation report, you'll hear them called, and you say, oh, you gave this part to me, or you designed this part in NX. I translated it, and now I have it in SolidWorks. I'm going to run a comparison report to compare NX and SolidWorks and make sure that my geometry that I get is still good geometry, and that it matches the source. And that's a really important thing. At a base level, is just to verify that geometry. And then what we've completely done is eliminated any manual data reentry error that could occur in that cycle. Yeah. And that's one piece. It's one piece of information that sits on your drawing today. There's geometry, and that's this. They're the annotations, the dimensions, the tolerances, the notes, the flag callouts, the material identification. They're attributes that's often information like the part number, the description of the part, bracket number 3. That's my favorite name. Jennifer's bracket number 3. And so we have all that information on the drawing today, and we pull that good stuff that we have on the drawing, we pull that back into the model and represent it digitally, and then that information gets used and reused across that supply chain chasm, which often it is a chasm.
Yeah, well, because a lot of that stuff in the past was not included with the model. It was only on the drawings.
It was only on the drawings, right?
Or in some other, communicated some other way.
Right.
So you're saying that yeah, I can see where that's quite an advantage if that's all included with the model itself, because it is, as you said, there's one source for the truth.
There's one source for the truth. Now, I'll give you a little tip. Don't think that's all coming in one file. Okay. It may be multiple files aggregated together. And if you want it in a single file, then you're not paying attention to the future. Look at big data. This is an aggregation of data that we're layering on in different ways. And the key is to keep it all connected together. So you may or may not be able to get that all in a single file that you send. So that's something that it's just a tip.
Yeah. No, but it's a good valid point, is because you're really talking about managing data, not necessarily managing files.
That's right.
And data is a model, data are specifications, and you said it's call outs, it's dimensions, it's whatever it is. And whether they are in the data file itself or not really is inconsequential, as long as you know what the data set is. That's and it comes and is connected together. And if I design it like this, and the next step in the process can use it like that and keep the data together, and the
Right.
next step in the process can keep the data together. I
Yep.
think that to me would be one of the more important things that you'd want to try to do.
That's right. That's right. And the hard transition for people is to transition from, that piece of paper. It's really
Yeah.
handy because it keeps everything kind of in a box.
Yeah.
Keeps all your data in a box, but it's also very limiting, right? We can't link to other data that we might want to also see. We just in the last 2 weeks ran some user feedback studies on a piece of data, and one of the biggest pieces of feedback was, "Oh, I want to link to all the other pieces of data." And we had published out a single file to view, which is this is a thing. It's like a 3D PDF. You can
Mm-hmm.
view a single file, but it's not integrated into all the rest of the data
Mm-hmm.
because we took it out of its product lifecycle management system or its data, cloud, if you will, of information. So keeping the connectivity of the data is really important. And I mean, there's a whole bunch of technology around that. So
Yeah. Yeah. So this is it's amazing to me. My brain is just rolling here, right? Because there's a billion different directions we could go with this.
Yep.
But as you look at this, what are the exciting things that you see that you go, wow, if we fix this challenge, we are really gonna change the game with the model based enterprise.
Yeah. Well, I'll kind of keep focusing in on the quality loop because I have a lot of quality friends that are in digital metrology. I'm a board member on the Digital Metrology Standards Consortium, and they have definitely educated me in the impacts of how quality professionals have to the amount of time they're spending evaluating a drawing so that they can prepare a quality plan that accurately inspects parts to ensure that they're going to meet their form, fit, and function requirements. So working on a webinar that we're going to deliver next Tuesday, and we're talking about a 50% time savings in
Wow.
duration because you're eliminating some huge manual entry steps. So 50%
Wow.
time savings is pretty big. And I want to caution people that this is not about, oh, well, I can lay off 50% of my workforce. No, think about it as your throughput is going to increase by 50%.
So
So
you're talking about
yeah,
the quality, the throughput in a quality department
yes.
and I'm not talking about, first article, getting something set up in the beginning, but you're talking about as we go along on a
Right.
production basis.
Yeah, as you go along on a production basis, as
Wow.
you make changes to your parts, you're so much better informed about how your parts were operating before because of this data you're aggregating, collecting,
Yeah.
and continuously feedback. I mean, it was a huge deal to me because even when I built all this spacecraft stuff that did go to space and did work, so I'll take that. But
Yeah.
I just threw it over the fence and they made the part. I had no idea. I had no idea if they were meeting the positional tolerance to this hole that I'd painstakingly done all this ridiculous fastener, tolerance stack up to make sure I had the right fastener size and all this kind of crap, right? Like
Yeah.
no feedback whatsoever. So I have no idea if I made a super expensive part because I had too tight of tolerances because I didn't really know how the part got made.
Yeah.
And so that feedback loop to me from the inspector is just, it's mind blowing. I mean, I remember going, huh, what do you mean? What do you mean you didn't make that within 20 thousandths? That's the only way it'll go together, and so I think the feedback loops are really important, and there's so much opportunity to leverage once you get the data authored digitally in a standardized, repeatable, mathematical way. And
Yeah.
it's harder than it seems to do that. And had that back to, why did I write the book? Well, that's why I wrote the book. And then I, added some more learning on it
Well, and
that we
yeah,
released this year.
Yeah, I just said, I'm just sitting here thinking about this, and when you need the book because you want to start everybody designing the same way, because
Yeah.
if I'm going to communicate to 3 steps down the road
Yeah.
and Damon designs differently than Jennifer does,
Yep.
than Sue, than Dan, I
Yep.
mean, that just blows everything out of the water that you wanted to do with sharing the data across all the places, because they have to adjust to each person designing.
hmm Yep. Well, if you have bad data, you're
Yeah.
going to get bad results. So,
Yeah.
so
Yeah.
you got to author good data.
Yeah. You
Yeah.
gotta author good data. I'm gonna write that down.
That's my Texas grammar coming out.
There you go. Well, it's critical. I mean, when we talk about this, and we talk about the the efficiencies, and we talk about things like what you really gain from designing consistently, and we look to the future. I mean, the future is not us walking around in manufacturing with a bunch of paper drawings and
No.
measuring junk with calipers. I mean, it's
Yep.
not touching. It's in the machines measuring, all different kinds of things that are going to happen that are well
Yeah.
beyond this. And
Yep.
what I think anyway, you're really doing is helping to lay the foundation for that, but
Yep.
with the book and getting people designing consistently in an
Yeah.
organization.
And even though you do this for like really complex geometry parts, where it really makes sense, because drawings are totally inadequate for complex geometry parts, even airfoils. I'm just like, really?
Yeah.
We're documenting this thing in 2D? Really?
Yeah.
So when you've got really, really complex parts and geometry, this totally makes sense, because your drawings are absolutely flawed from the get-go. I can guarantee it. You give me a drawing today of a complex part, I will find something wrong with the drawing or
Yeah.
misinterpret something, which is what's really going on. Um,
Yeah.
so, but it doesn't mean that if you have some washers, that you do want to do little spot checks with calipers and get yourself some Meditoyo digital calipers
Yeah.
and just measure them right along, and it'll pop it into a spreadsheet for you. That's still okay. Don't change that business,
Yeah.
because there's not a lot of value add with a lot of complex, systems for a washer that has like 3 things you're going to check, right?
Yeah.
You got IDOD thickness, right? Okay.
Yeah.
Don't change your business for that. And I just recently said, well, I had an executive say, well, how are we going to deal with the data, you know, if we still have these manual processes? I said, well, just keep doing business the way you're doing now,
Mm-hmm.
because that works, right?
Yeah.
So don't change that part. And that's the other thing. You don't have to do a complete overhaul. You can really focus in on your complex systems, and build that digital traceability through there. And then, once you've got that figured out, some of the smaller piece parts shake out and make sense.
Yeah. So where do you see, what industries do you really see? Are there any
Mm.
segments that you see that's really coming in, or I'll ask some follow-up questions, but
Yeah, this is always a hard one for me, because it's really all industries can benefit from this, because they make parts.
mm-hmm.
If you make a widget that is in 3 dimensions, you can pretty much gain value from this. And they're, even if you're building like a fabric, like a cover for a car seat or something to that effect, there's still value to having some 3D data that is established and then reused.
Hmm.
And then you have to flat pattern it and stuff like that. And same thing goes for sheet metal, right?
Yeah.
You've
Yeah.
got sheet metal parts that you flat pattern. Well, the CAD tools are great at building sheet metal parts and then flattening them out for you, and then you just go bang them out in the plasma cutter.
Yeah.
That's of high value. So certain, I would say, fabrication methods have advantage over some others. The most obvious, if you 3D print anything, you must have a model. This is one of my
Mm-hmm.
favorite quotes from my friend Curtis Brown. He's like, if you're 3D printing, you have to document it in 3D. There is no other way, right? Because you've got to feed that model into the 3D printer. So that right off the bat, anyone who's doing anything with a 3D printer, there's value. I think all industries now have 3D printers. I mean, I got one in my basement. So yeah. But we do see this in the high criticality industries. So as you pointed out, spacecraft, gotta work, gotta fit, that kind of thing. Automotive, they're looking at this so that they can increase their throughput because cost is such a big deal, bottom line. So there's another industry. Medical is using it, medical devices, I'll say, is using it. Obviously, also, they're doing all sorts of interesting things with materials and 3D printing. And I mean, so there's so much value. Is it all, do we hit geometry, annotations, attributes, presentation states, and the product structure in every single data set and every single industry? Probably not. But people are finding value for geometry. I mean, that's kind of an easy one, right? My geometry should always be leveraged throughout the whole life cycle of the part, no matter what. So we do see a lot of this heavy in the aerospace and defense, primarily because of the criticality and the fact that they do have money to spend on first article inspection processes.
Yeah, and when you have very high dollar components that you're looking at, and the investment in some of it, especially if you're trying to cast something, then do some more processes, and a lot of times you get a lot of processes after that. So you take a pretty expensive alloy, you cast it, and then you have an more expensive piece of alloy that then gets machined and then gets multiple processes after it, and more fabrication and whatever else, and you can have one component that's hundreds of thousands of dollars, and you definitely, that first article and the at each point you're in process kind of stuff too is critical.
Right. Absolutely.
Wow. Yeah. It's just so interesting that to listen to you talk about this, because the uses are mind-boggling.
Well, I don't even know what they all are yet, right? Yeah. Right.
Well, and that's the kind of thing, because you're like I don't know the right metaphor for it, but you're like standing at this big open field and you're like, what direction can we go?
Yeah.
Because all the directions kind of make sense. Some are more obvious than the others, but there's so many ways. And I'm sure that you uncovered new reasons, new benefits, new things that you go, wow, this really will make a difference in this application.
Yeah. And it's a constant conversation about what the little benefits are. It is, there's a lot of opportunity out there. And my job is to help people get their data digital, machine readable, without limiting, so that sort of that future opportunity that we don't know about. So I do have a crystal ball here. So I use this occasionally because sometimes I don't know.
Yeah. There you go. I need one of those. One of those. If people ask me stuff, I'll just look at my crystal ball.
There you go.
That's awesome.
I'll send you a link.
That's awesome.
Yeah.
You're so great, Jennifer. Well, let's just talk a little bit about how you're typically helping companies, and a little more specific about when Action Engineering goes in and you're helping these companies. What are you typically doing with them?
Well, our goal is to get people to create and then use and then reuse and automate their 3D CAD data. And we're specifically doing that in that design, fabrication, inspection space. So from engineering, to supplier, for original designer to supplier, in many cases. But we're trying to do that in a way where we are trusting the data as it moves from left to right in its life cycle. And so some of the things we do are at the very beginning, we just help them kick off and
Mm-hmm.
build an executive pitch. Like, what is this? What are the benefits around this? And we have social scientists and organizational change management people that come in and work with companies to help them see what the benefits are for their company. And then we marry that with our technical expertise around the CAD systems and what it means to author model-based definition data. So we oftentimes build a proof of concept for them. So we
Yeah.
go, okay, give me your drawings. And we get a drawing and we convert that into model-based definition, and then we show them the kinds of things you can do with it. So, because that's kind of the hard part. If you get into this space, you're going to spend about 2 years dorking around with learning the technology and stuff like that, and we think you should be able to do that faster.
Yeah.
So we like to bring our expertise, we kind of kickstart that for you, and then we move you into, okay, now let's be very specific about your downstream activities. We want those consumers to adopt what you're going to author. So let's make sure we understand who's taking the next step after it leaves engineering, because engineers are easy. I mean, we can convince them of this all day long because, you know, they
Yeah.
can already sort of see the future, based on their training that they've had. So, but if you take it on into a shop floor, there's a little bit more hesitancy around this 3D data and what does it mean.
Yeah.
So we call that our consumer adoption strategy. Then we do a kickoff workshop and build a team, and then we're there kind of like coaches, like track coaches, just to make
Yeah.
sure you're up in your sprint game or up in your
Yeah.
long haul runs, and there to keep you on track with figuring out pilots and stuff like that.
Well, it is because now I'm sitting here thinking about it as you're talking about it. We're talking about a change that affects the heart of a lot of operations.
Yeah. It is.
Especially in
It
manufacturing,
is.
when you
You're
talk
right.
about component data, whether it's drawings,
Right.
whether it's, scratch it on a yellow pad, that data around the components and the assemblies
Yeah.
and everything that they build
Yeah.
is the heart of there. So you're really teaching them how to change their thinking, their practices around
Yep.
that. And it does take not just laying it out, like you said, in the first phase, but then
Yeah.
you have to show them and
Yep.
then probably prove that it works through the process for them,
Absolutely.
help them do that.
That's right.
And then in the end, it is, as you said, coaching and helping over the long term to ensure that it doesn't just go back to, oh, well, it's not working so great here, so we're going to go back to this.
Yep.
And pretty soon the workarounds are as big as as the system was before you started. If you don't really get the habits ingrained to go, this
Absolutely.
is how it needs to be
Yeah.
done. If we need to change, it has to stay along these kind of lines so that we can use the data all the way through.
Right.
Wow.
Yeah.
I have learned a ton.
Oh, good. I'm glad.
I tell you what, I hope that if people listening are as engulfed in this, because this is, coming from a business that I said, we had to use model-based design information to program, to do other things, but we really didn't use this. There's so many pieces of paper that were
Yeah.
associated with that. It was like,
Yeah.
I can't. And like I said, you had to get enough dangerous to pull that paper kind of information off the models, because you couldn't really just use the models.
Right. And I think this allows us an opportunity to simplify some of that complexity that has kind of blossomed out of a drawing based culture.
Yeah.
And that's a little tricky to kind of put that back in the box, if you will.
Yeah.
But sometimes with all that drawing based processes that we had to establish, because the technology was where it was at, we're not really sure why we're doing all that stuff. So we end up doing a lot of current current process mapping and then future process mapping,
Yeah.
so that you can see the difference and see where the simplification can occur.
Yeah.
Yeah.
Wow, it's so cool. It's so cool.
It's not boring.
No, it's not.
Constant
It's
challenges all the
yeah,
time, both people
yeah,
and technology. So
yeah. And it
it's a
is the kind of
fun
thing that,
problem to solve.
yeah, yeah, no doubt, no
Yeah.
doubt.
Yep.
Well, Jennifer, thanks so much for being here today. I just appreciate that you were able to stop by and share this with us. And if people want to get a hold of you, go to what's the best way? Go to the Action Engineering website, reach out to you on LinkedIn. What are some of the places that?
LinkedIn is a great place to find me. I'm Jennifer Herron, Herron, Golden, Colorado, probably is what it comes up as.
Yeah.
And it's action-engineering.com. And there's a contact us form, and you can get a hold of us there.
Awesome. Awesome. Well, thanks so much for being here today, Jennifer. And
Thank
thanks
you.
everyone for listening
Appreciate your
again.
questions.
Oh, again, it was just a pleasure. It was a pleasure. I feel so fortunate that we were able to do this. So I don't even know what I was going to say other than thank you.
You're welcome.
We will be back again on Thursday with another show with some more interesting people talking about business and manufacturing and not, I don't know. They're going to lot to live up to after the model based enterprise discussion today, because it's really intriguing to me, and I love the subject. So thanks so much for sharing today.
You're welcome.
And we will be back again. Thanks.